This is neither a galaxy nor an alien planet. This is just a soap bubble.
Few days ago, one of you asked a simple question: how does a soap bubble look under a microscope?
And honestly, I didn't want to disappoint the subscriber. I wanted to make this experiment as perfect as possible. And because if something as ordinary as a soap bubble could hide an invisible world inside it, I wanted to see it properly. At first, the experiment looked simple. I used a hand wash and some amount of water and created bubbles and thought I would be able to look it under the microscope, all those fascinating colorful pictures. But I was in disappointment. Now here you can see I'm using the water along with the soap Dettol to create some bubbles. But however, the soap bubbles are not stable. I'm trying to create soap bubbles, but these soap bubbles are not getting stable.
So what I discovered next thing was that if I use the pipette to blow air inside the soap solution, I was able to get good amount of bubbles with a decent shape and decent size also. So I tried this, but even after then I was able to get a good number of bubbles with a decent shape, but the problem was those bubbles were not stable. They were also getting burst within quite a less amount of time. So I realized these bubbles were not stable because these bubbles get evaporated and they get burst. So I, after doing some research, I understood that when we add glycerin in the soap solution, the stability of bubble will increase and they will last longer without getting burst. So now I'm adding some Dettol solution. I created a new solution right now with Dettol, water and glycerin, and right now the bubbles were stable in this time. Now after getting the stabilized bubble, let's look it under the microscope. So this is how it was looking under the microscope, the bubbles. You can see the joints, they are perfect joints. In every joint there's only 3 connections, there are only 3 film joining. It is not 2, not 4, not 5, anything. Every joint consists of only 3 joint, 3 joining from the neighboring bubble side, the border thin film. So this is how it was looking when the light is from bottom. So I thought like why I am not getting a colorful image. So I was doing some research, but understood that this kind of image can come only with the light is from the bottom, and if I use the top illumination, then I will be able to use some interference pattern, as I told earlier that. So after doing some research, I did one thing. I plan to switch off the illumination from the bottom and used a cardboard, hard cardboard, so as to block any light coming from the bottom. And now I kept the solution within which bubbles are made on top of it. And the important part is illumination I used is from the top using a small torch. You can see the bubble right now, and the important thing is adjusting the illumination angle so as to get a interference pattern in this bubble. So after this bubble, now comes the discovery which I was actually happy, and this is how it was looking under the microscope, the bubble soap film under the microscope. You can see the film, colorful film with different colors. Basically what is happening is right now you can see the color is disappearing. So what happens is that there is interference pattern between 2 rays, which one which comes from reflection from the top of the bubble, and one which comes in the after refraction and reflecting back. The interference between these 2 rays either can be constructive interference or destructive interference. When it is constructive, at times some colors get cancelled off and the other colors is visible from this side, and when it gets destructive it appears dark. So you can see the colorful patterns moving like an amazing painting. So this is the interference pattern. So it is not mandatory that it can only be seen from a high-end microscope. My microscope is a basic low-end model microscope, but still you can see the patterns visible under this thing. One thing also which I noticed is that it is based on the angle of the light and also the thickness of the film. So when the thickness is optimum, when it is not too thick, when it is too thick, no interference happens and you will not be able to see any color. And when the thickness reduces due to the weight of the water molecules, it gets thickness gets reduced, and now the interference happens. So when the thickness reduces further, you can see the color disappearing now, and it's mostly turning into white. It is because this thickness is so thin that no more interference patterns can be formed. So these are the various interference patterns from various samples which I have taken. You can see how beautiful it is. What fascinates me most about microscopy is not just the science. It's a realization that even the most ordinary things around us can become extraordinary when we truly observe them. A simple soap bubble, something we normally ignore every day, contains moving structures, flowing light, and invisible worlds hidden inside it. Maybe that is the real beauty of science, not just discovering new things, but learning to see familiar things in completely new ways. And if an ordinary soap bubble can hide an entire universe of color, imagine what else is awaiting under the microscope. This channel is about exploring hidden worlds invisible to our naked eyes, from soap films to microorganisms to microscopic structures hidden all around us. If you're curious about the unseen side of the reality, kindly subscribe and comment what would you like to observe next.